Another way we can have a CO2 win is by improving construction design and construction process. And that's exactly what Matt Bolle from Danley is going to be talking about today. A new way of design for ground slabs. Over to Matt. Thank you.
Right, good afternoon, everybody. Thank you, Steve. My name is Matt Bolle. I'm the National Sales Engineer for Danley. I'd just like to start by saying thank you to Britpave and Steve Elliott in particular for inviting me to present at this event. I must admit I was at first excited and then a bit filled with dread at the thought of having to present at an industry conference. But I thought it would be a great platform for me to share with you all what we are doing at Danley. So my presentation today is going to give you a brief insight into Danley's innovative and alternative design methodology or design solution for concrete ground-supported slabs, specifically relating to concrete hard standings, which we hope is going to change the way that we design and construct concrete hard standings within the UK. But it's something that's already been talked about sort of quite in depth already, but I just want to touch upon sort of innovation within the construction industry. So innovation in construction typically lags behind other industries such as pharmaceuticals, technology, and automotive in terms of how much revenue we put back into R&D processes, which stands at about 1% compared to about 3.5% to 4.5% that we see in the industries that I've already mentioned. A recent survey also showed that 2/3 of our colleagues in the industry, so architects, engineering, and construction professionals, also believe that the industry is not evolving fast enough to meet the changing needs of society. So in construction, innovation is typically viewed as risk. And in an industry that is often depicted as being highly risk-averse anyway, it means that the challenge to actually be more innovative is often quite difficult. And what compounds this issue further is the siloed nature of construction, is we typically have a multitude of individual companies, organizations, or even people that changes from project to project, which really makes the whole collaboration piece and innovation and developing an innovative culture an almost impossible task. Now, developing an innovative culture is becoming more of a necessity than a choice as it used to be. A key driver for this was the introduction of Construction 2025, which was launched by the government in 2013. And that really called for the industry to make improvements in efficiencies towards project costs or lowering project costs, reducing emissions, and improving delivery times. But equally, these are the same measures or the same pressures that are put on each facet of the supply chain in order to win work on a day-to-day basis. Now, these are significant targets that they've proposed and put forward. And without some form of innovative or, in some cases, revolutionary changes to how we do things, we are unlikely to achieve those targets. But why am I sort of talking to you about, innovation in construction, and what does Danley actually have to do with it, and how can we help? Well, we can help towards achieving those targets, at least within the realm of ground-supported concrete slabs in the field in which we operate, by using what we call our strategic reinforcement design solution. And that is what I'm going to be talking to you about today. So if we start by looking at why concrete hard standings actually fail. Concrete hard standings typically fail through fatigue and gradual degradation of the material over time rather than through a catastrophic failure related to an excessive load, for example. And what we typically see as well is that the maximum load that a pavement or hard standing is subjected to, whether that is the wheel load or the axle load, that's going to remain the same throughout the life of the pavement. The variable that we do come across is the number of repetitions that pavement or hard standing is going to be subjected to, depending on the type and size of facility that we're designing. If we consider that if we consider the impact of increasing load repetitions, particularly when we have an increasing width in the joint opening between subsequent panels within a pavement, we can see that load transfer efficiency on the left there through the mechanism of aggregate interlock actually diminishes quite rapidly between 0.5 and 1 millimeter joint openings, which is what we will typically come across in standard pavements in the UK. What's important to note as well is this graph only covers up to 1 million load repetitions, when in reality, for industrial concrete pavements, we are designing for considerably more load repetitions than that, up to 15 and sometimes even 20 million standard axles or load repetitions. So again, so what does load transfer efficiency have to do with concrete hard standings and pavements, and why am I talking to you about that? So one thing that we do know is that joints are the weak points within concrete slabs. And if we want them to perform consistently, particularly in the longer term, that they need to be designed to provide long-term stability. When we talk about stability, we're talking about slab deflection. So that's slabs moving relative to one another in the vertical plane. And that movement is directly related to the load transfer efficiency between slabs. So where we have low load transfer efficiency, we tend to have unstable joints that cause the slabs to deflect excessively under load. This instability causes the slabs to rock and to fault, and ultimately causes the joint to fail. By controlling or limiting that amount of deflection between adjacent panels through an appropriate load transfer mechanism, such as a plate dowel or standard round dowels, the joint will remain stable for the intended design life, and you'll get better performance in the longer term. Another significant cause of failure in concrete slabs on ground is restraint. So we all know that concrete shrinks after placement, it likes to move around, and that most of that shrinkage actually occurs at the corners of panels, where you have either sawn or formed joints. And this is because the panels are shrinking and pulling in towards their centroid of the shape. So the overall direction of the shrinkage is in a diagonal direction away from those corners, away from those joint intersections. And that's where you have your highest stresses. So at these intersections, whether they're formed with straight round dowels or steel mesh reinforcement running through them, you've got an element that's trying to restrain that concrete and prevent it from shrinking and pulling inwards. So the stress or the restraint caused at these corners or these joint intersections leads to an increase in stress within the concrete at these locations, and that increases the likelihood of cracking to occur at these locations, as shown in these pictures. So everything gets locked in to that point. Concrete builds up its stress, and that stress is relieved outside of the joint location. So where does Danley and strategic reinforcement design sort of come into all of this, and how can we mitigate that and help mitigate the issues that we've just highlighted? Well, to start, what we're trying to do is propose a fairly significant change in the way that we approach designing and constructing slabs on ground. And to do this, by doing this, we will offer the best value to every part of the supply chain in terms of the performance, cost, time, and sustainability. Now, for us to be able to do this, there needs to be a shift away from traditional methods where we use fabric or mesh reinforcement towards methods that focus on designing the elements that are actually the root cause of failure, which fundamentally comes down to better joint design. But what does that actually mean? So let's take a little bit more of a closer look at what strategic reinforcement design does in terms of key factors. So the first element of strategic reinforcement design is superior load transfer. So steel dowels, whether they are round, square dowels, plate dowels, or taper plate dowels of different geometries, provide superior load transfer efficiency compared to aggregate interlock, especially where you have joints that open between a quarter or up to about a quarter millimeter. But more importantly, dowels, actually provide a more consistent load transfer efficiency and are not susceptible to the same variability in performance that we see with aggregate interlock, and especially coupled with high load repetitions. This just shows you the PD3 tapered plate dowel that we utilize in our strategic reinforcement design solution. So that will be placed at all of your sawn joints within the pavement. and then Danley dowels that are used at construction joints. So a much simpler solution with effectively only two joint type or joint solution types. This, however, is only part of the answer. The second part of what strategic reinforcement design does is allowing free movement at every joint. So it's all about how we can avoid restraint at the joints, where we know we've got this diagonal shrinkage stress that's coming in. But what's more important than just talking about free movement is is the need for two-directional free movement that allows us to accommodate that diagonal shrinkage or that diagonal stress induced in the concrete when it tries to shrink within each individual panel of the concrete. This is where consideration needs to be given to the type of dowel that you use. So a straight round dowel that we typically see on most installations will allow shrinkage in one direction, but it's going to add restraint in the other. Where you use square dowels that have compressible sides, you are allowing that two-directional shrinkage of the concrete, so you're reducing the amount of stress as it shrinks. The same can be said for standard rectangular plate dowels. And then tapered plate dowels rely on their geometry to allow that two-way lateral shrinkage of the concrete to avoid and mitigate the stress that builds up within the concrete. That comes down to creating voids either within the concrete itself, as shown with the PD3 dowel on the left, or with the Danley dowel within the pocket former that you attach to your formwork. The third factor that's key in what we do is strategic joint spacing. So we typically work to a rule where joint spacing is directly proportional to the design slab thickness. And this rule we work to typically limits the joint spacing to 24 times the design slab thickness to ensure that the slab has enough stress relief points to avoid cracks forming outside of the joints. Now, it's quite a simple concept. The more controlled cracking that we have in the form of joints, which are effectively controlled cracks, the less likely we are to have mid-panel cracks. And cracks are uncontrolled joints. So effectively, they're both doing the same thing. And if we have no mid-panel cracks, then there's no need to install any crack control mesh. So all of the mesh that we would typically see in the traditional concrete pavement or hard standing for an industrial facility can all be taken out. So simply by reducing your joint spacing, you can significantly reduce the number of cracks from forming across your concrete slab installation. Right, so hopefully that all makes sense. I know it's quite a lot to take in within just a few slides in a few short minutes. But what I hope becomes clear and what you can see is that the fundamental issue that we have with current concrete slab design and performance actually relates to the concrete slab design performance relates to joint design and behavior. And that is something that we do not currently give enough attention to within our current design guides, particularly for external hard standings. So why should you consider a strategically reinforced design solution for your next concrete hard standing? What are the benefits of actually switching? You get improved long-term performance and serviceability because you've got improved load transfer at every single joint. Your pavement is going to perform better because that is the weak point. That is typically where the pavements fail and degrade. You can have thinner slabs. So due to the higher load transfer efficiency at all of the joints, which typically when you look at how you analyze a load at a joint is going to be the controlling factor. The better you can share that load between adjacent panels, the thinner the concrete can be. Because you've got thinner slabs and you're taking out all of the crack control mesh, you can also have lower material costs. You save on installation costs as well. You've got less concrete to install, less steel mesh to install. The cradles that we use weigh 7.5 kilograms compared to a sheet of mesh, which can weigh up to 70 kilograms. So there's less labor time involved with setting up and preparing for the actual concrete installation. Because you've got reduced materials, you've also got reduced carbon. So if you're reducing your concrete percentage by 15 to 20%, you're going to be saving that amount of CO2 related to the concrete elements of that works. And the same with the steel. typically for strategically reinforced external concrete service yard, the steel saving can be anywhere between 50 to 80% by weight. So there's a considerable amount saved there. All of this perfectly aligns with the goals of Construction 2025 and the pressures that we all face within the industry to do things quicker, to save on costs, make it more sustainable. So by simply switching to a strategically reinforced design, you're going to tick all of those boxes. Now, for most people, strategic reinforcement will be a relatively new concept, but it's actually been around for nearly 2 decades in the US and Australia. And Mike will probably be aware of this, and he probably knows some of my colleagues in the US. So we've been doing this for quite a long time for a number of really high-profile clients that you will all recognize on there. So it's nothing new. So when we say it's innovative, it's not something that's just come out, but it is innovative in terms of what we do within the UK market. I just briefly want to talk about a couple of projects that we have done in the UK. So in the US, we've done over 300 million square meters of concrete slab on ground. When I started the Danley journey 2.5 years ago in the UK, that counted for absolutely nothing, and it still does. So the projects that we've done here, whether they're 100 square meters or 2,000 square meters, hold a lot more value within the industry than 300 million square meters. So I just want to share some of the wins that we have had with this solution so far. So this was a project we did for Next PLC at South Emsall with Adept Consulting Engineers. So this was completed in summer 2020, and it was a yard extension for the new high bay warehouse extension that they were putting or building alongside one of their existing warehouses. It's probably only about 2,000 to 2,500 square meters in size, so relatively small. But on this particular project, we changed the specification from a 200 mil thick C32 concrete with A393 mesh to a 165 mil concrete with all of the steel taken out and just Danley dowels and PD3 dowel cradles placed at all of the joints on a 4-meter joint spacing. The final installed cost saving, as per the contractor that we worked with, was just under 18% compared to what they had specified originally on the design. Just a finished shot of the loading bay area. And then a more current project. So this is Siemens' train manufacturing facility in Goole, which is currently on site. So they've probably done roughly a quarter of the site, which is just under 30,000 square meters. Now, the original specification on this, because of the sort of unique vehicles that they had accessing this pavement, which was to transport the train car bodies between buildings and eventually to the rail line, called for a 340 mil thick C32 concrete slab. By engaging with ourselves, Adept Consulting, and working with GMI Construction, we managed to reduce that to a 295 mil thick slab, again with all of the mesh coming out, and just PD3 dowel cradles and Danley dowels at the joints. Joint spacing on this, because of the slab thickness, is about 5 meters, and that's typically where we would sort of cap the joint spacing. So even if you went up to a substantially thicker slab, we'd still try and maintain the joint spacing at about 5 meters maximum. Just a couple more slides of the project. So you can see installation typically follows the same long strip technique that we use in the UK. And those strips can be either poured in single strips or double strips with a saw cut down the middle. And that all comes down to the capabilities and the preference of the concrete contractor. So I've just got a few final thoughts in closing. And I think a lot of this has been discussed by the various speakers before me. I would say that these thoughts aren't really specific to Danley or our solution, but I think it's rather a call to action, and I don't think it's necessarily reflected within this room. I think it's the industry as a whole, because I think what I'm about to say sort of aligns quite well with what Britpave is trying to promote within the industry. So firstly, I think we need to be bolder, whether that's with technology, with products, with processes, etc. the construction industry as a whole needs to try and foster a more innovative culture, which I know is difficult, but we need to change the way that we approach things to work together more effectively. This has been mentioned by, I think, pretty much every speaker before me, but we need to be more collaborative. We all talk about it, but we don't really do it. Early on engagement is always going to be key, and we've got countless examples, typically on really large, high-profile projects in the UK, where, because of the complex nature of the problem and the challenge that they face, they have engaged early, they have worked collaboratively, and that has often led to those groups of people delivering exceptionally innovative solutions and processes off the back of that. The third one is don't be afraid to do something different. So I think it sets you apart from your competition, if you see it that way. Otherwise, we typically all end up in this race to the bottom line, you know, counting every penny, trying to make it as cost effective as possible. And that dilutes your value as an individual, but also your value as a business or an organization. And I'm just going to end on a quote from a lady called Grace Hopper, who served in the US Navy. And she stated that the most dangerous phrase in the English language is, "We have always done it this way." And I think this view is particularly common within the construction industry, and it's something that we should be actively trying to change for the better. Thank you very much.